So before you start, I really encourage you at home to try this 2.3 deriving the circle equation on your own. It's not too difficult, and it really helps develop those conceptual understanding of why the circle equation is the way it is, what it actually means, and what each part of the circle equation is. So for this first part, okay, it asks us to take the center and to take a point x, y, and to find the radius. So the radius is going to be the diagonal length from the origin to the point. So you'll see it in the blue. And if we want to solve for that length, you'll notice that I drew a right triangle. That right triangle can give us the idea that we're going to be using the Pythagorean theorem. So a squared plus b squared equals c squared. You'll see this in part 3, where I solved for an actual number for the radius. So that's just kind of the general idea of what a radius is between 2 points. But what happens in part 2 is we're given that the point is at the origin, and we're given an arbitrary point x and y. And we want to think, okay, what is that corner right point down at the bottom there, where the vertical and the horizontal line intersect? And the answer is it's on the x-axis, so it maintains the x value of that arbitrary xy point. But it's 0 for the y because it's not actually going anywhere up or down. So we find those 2 points, and we can find the radius using the same way. So instead, the horizontal distance is x minus 0, and the vertical distance is y minus 0. Okay? Now number 5 plugs it into the Pythagorean theorem. So you'll see a squared plus b squared equals c squared. And it looks a little bit weird because we have x minus 0 squared, but that x minus 0 just represents that distance in that horizontal. Okay, so we're still using the Pythagorean theorem, and this right here actually will give me the formula for a circle when we're centered at 0, 0. So this is a very special case, and it doesn't work for every single circle. But what does work for every single circle is part 3. So part 3 gives us an HK, and HK is your center of your circle. So this is the center, and you have your arbitrary point x and y. So what I have to do is I have to find what that corner point is. So x is the furthest of the horizontal values, and y and h is the smallest. So in order to find the distance in between, you subtract x minus h. So for those of you who were with me when I was talking about, okay, if it's the distance between my desk and the door, and then I'm standing in between the desk and the door, and I want to find the distance between me and the door, then I can take the distance from the desk to the door and subtract the distance from me to the desk and find that distance in between. So what I was just talking about is, here's me, here's my desk, and here's the door. So if I take the distance from the desk to the door and I subtract the distance from the desk to me, that means ultimately I'm going to find the distance in between. And that's what's going on here when you have the x minus h. So the h is the x coordinate of the center, and the k is the y coordinate of the center. And we still are going to use the Pythagorean theorem, a squared plus b squared equals c squared, but this time the distance is x minus h for the horizontal, y minus k for the vertical, and r squared is still representing the radius. So r is the radius, but in our Pythagorean theorem, r squared is in the equation. So this right here is a very important equation to make sure that you have somewhere down in your notes. X minus h squared plus y minus k squared equals r squared, where h and k is the center and r is the radius. Notice that you do have negatives or minus signs already built into your equation. So what I want you to think about is what happens if I have a negative point as my h value for my center. Like, for example, if the center is -3, -1, what would happen to inside the parentheses when I plugged in a negative value? Yay! Okay, well, I hope this helps with deriving the equation of the circle. We're going to start looking at some more practice problems in the next video.